Now, you can't use the zero factor property unless you set the quadratic equal to 0. So in this case right here, I have x squared on one side, so it is a quadratic, it's second power, but it's not equal to 0. And since it's not equal to 0, I can't use the zero factor property. So, first step is to set it equal to 0. So I am going to take everything on the right side and put it on the left. All right, so I'm going to minus 5x minus 14. These cancel out, and that leaves me x squared minus 5x minus 14. You might be tempted to combine terms over here on the left, but there are no like terms, right? The first term is squared, the second term is a first power, and the third term over here is a constant. So you cannot combine those terms. You have to keep them separate. At this point, we have a simple trinomial, meaning it has a one leading coefficient. So we can break it apart. Square root of x squared is an x. It ends in a negative, so you can have a positive and a negative. And we're looking for two numbers that we can multiply together to give you a negative 14. Right, 1 and 14, 2 and 7. That if you add together would give you a negative 5, right? Now, because you end up with a negative, you know the stronger number must be negative, and the weaker number must be positive. So multiply it together to give you a negative 14, and add together to give you a negative 5. So the first one gives me a negative 13. That's no good. Second one, negative 5, and that is good. So it looks like this right here is what you get. Now, again, once you get to the point where you can do this mentally, with a little bit of practice, you will. You don't have to write all this out. I'm doubling the amount that I have to write out to do this, but again, don't feel compelled to write everything if you don't need to. If you can do it mentally, more power to you. Just make sure you get the right answer. Okay, so we have a positive 2, and we have a negative 7. I kind of covered it up there a little bit. Negative 7. Okay, so that means, now at this point, we know that x plus 2 multiplied by x minus 7 is equal to 0. Therefore, x plus 2 must be 0. 0 times anything is 0. Or x minus 7 is 0. Anything times 0 is 0. I know it's like a 6, but it's not. It's just 0. Okay, now, so we say x plus 2 is equal to 0. X minus 7 is equal to 0. Minus 2, cancel, cancel. X is equal to negative 2. Plus 7, cancel, cancel. X is equal to 7. And we put it in set notation. Negative 2, positive 7. Oh, that looks terrible. There we go. Well, hopefully good enough. I'll do that and differentiate it that way. Okay, now again, you don't have to put negative 2, positive 7. You put 7, negative 2. That also works in this case. All right, moving on to the next one. This is a quadratic. It has a 2 exponent here. That's how I know it's a quadratic. If I want to solve it through the zero factor property, first step is set it equal to 0. You can't use the zero factor property unless it's set equal to 0. Okay, so minus 3x minus 28. Minus 3x minus 28. Cancel, 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 cancel. So we end up with x squared minus 3x minus 28. Okay, but basically if you're solving it through the zero factor property, it literally kind of tells you how to work it. First step, 0, set it equal to 0. Second step, factor everything. It's literally in the name, right? So this is a one leading coefficient, so I'm going to say x. Oops, I skipped a step, sorry. Square root of x squared is x, so I put it in the first place of both. It ends in a negative, so one will be positive and one will be negative. We'll do other kind of factoring later, but right now it's being kind of consistent with the signs. Later on, we'll do other ones. Okay, so at this point, I'm looking for two numbers that you can multiply together to give you a negative 28, and if you add together, we give you a negative 3. All right, so is it going to be 1 and 28? Is it going to be 2 and 14? Is it going to be 4 and 7? And it's going to be 4 and 7, right? Eventually, you're just going to do this mentally, though, right? So, again, the middle term is negative, so the ones on the right must be negative. But you can already see that when I add those together, I get a negative 3. So that's it. This is a little more compact form of doing it. You don't actually have to write down the result of multiplication right here on all the factors. Sometimes you just write one column, and then you find that you multiply together, you get a negative 28, and then you just add them together, and you find the one that will give you the correct sum. Like that, right? So it's a little more compact form, excuse me. So we know we're going to use a positive 4 and a negative 7. Make sure that you put the positive next to the 4 and the negative next to the 7, or you can flip the x minus 7 and the x plus 4, though, if you want to. But the positive must be next to the 4, negative must be next to the 7. Okay, so at this point, we factored everything. And now what this means, because the zero factor property is, it either means x plus 4 is equal to 0 or x minus 7 must be equal to 0 for the product to be equal to 0. So I am going to set them equal to 0 and solve, right? Minus 4, cancel, cancel, x is equal to negative 4. Over here, plus 7, cancel, cancel, x is equal to positive 7. And then finally, we can check our work, which is not such a bad idea. I'm being lazy, so I'm not checking my work. And then you put them in set notation like this. Normally the computer gives you these brackets like this, and you're just supposed to kind of fill it in the middle part. Don't put brackets within brackets. They're going to count that wrong, right? So don't double up on the brackets. That means something different. Okay, let's try the next one. So the next one, this is a quadratic because it has a 2 exponent right there. That means it's a quadratic. And if we want to solve this through the zero factor property, first step is to set it equal to 0, which means we have to get rid of everything on the right side. So we say negative 9x minus 18, cancel, 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 cancel. So we say 5x squared minus 9x minus 18 equals 0, right? Okay, next step is we're going to factor this. Now this one's a little more complicated because it does not have a one leading coefficient. This one's going to require a little extra work. First, we're going to multiply the leading coefficient by this constant at the end, right? The leading by the trailing coefficient. So we're going to say 5 times negative 18 gives me negative 90. So we're looking for two numbers that we can multiply together to give you a negative 90. That would give you, if you add these together, would give you a negative 9. Now, they must have the opposite sign because the constant, the trailing coefficient's negative. And we know that because the middle term is negative, the stronger one must have been negative. And you think about it, if you have a positive and a negative and they smash together and it ends up being negative, negative must have been stronger. If you have a negative and a positive and it smashes together and it's positive, the stronger one must have been positive, right? They kind of neutralize each other a little bit, okay? So because we know that the result is negative, all the stronger ones over on the right must be negative. So I'm trying to find the one that's going to give me a negative 9 when I add these together. So this part hasn't changed. So I'm just going to do the single column. I'm compressing it a little bit if you don't like doing it this way. You can separate them and do it the way I did previous to this. I'm just trying to make it a little more compact. So to get a, and basically I'm dividing, by the way. I guess I haven't really explained this, but 90 divided by 1 is 90, 90 divided by 2 is 45, 90 divided by 3 is 30, 90 divided by 5 is 18. And you're just adding these together, right? And you can write the results as you go along. I'm doing a lot of mental math, which probably isn't such a good idea. Can't really see what I'm thinking. 3 plus negative 30 is negative 27. 5 plus negative 18 is negative 13. It's not quite there. We're getting close though, right? So I can do 6 plus 15, where this is negative, and that would give me a negative 9. So it looks like these are the numbers I want. Okay, so this one's a little more complicated though, okay? So just try to stick with me. I know I've kind of explained this before, but let's stick with it for now. So we're going to put an X there and X there. It ends in a negative, right? That's a negative, so we're going to have a positive. We're going to have a negative. I'm going to put the 6 next to the positive, the 15 next to the negative. Okay, but we're not done. Normally, if this was a simple one, we'd be done at this point. But in this case, we're not done. We have that additional step of multiplication when it's more complex, and we have an additional step at the end. So again, when it's simple, you'd be done at this point. But since this does not have a one leading coefficient, you have a couple of extra steps, one at the beginning and one at the end. Okay. So what we're going to do is we're going to divide this by 5, and divide that by 5. Now, if it doesn't go in, we bring it to the front, so that gives me 5x. And we put the 6 there. That's why it's called slide and divide. And right here, since this one does divide, negative 15 divided by 5 is 3. You're done with that one. Okay, now at this point, we simply set these products, set these factors equal to 0. Fix my handwriting, sorry. Okay, now, this is what I meant before, where some of these are they're not as simple as just flipping the sign. You have to flip the sign and divide, so you might actually want to write out the step of setting equals 0, because these are a little more complicated. But go back to the logic. Factors, right? 5x plus 6 must be equal to 0, or x minus 3 equal to 0. If the product of those is equal to 0, one of those parentheses must be equal to 0. 0 times anything is 0, or anything times 0 is 0. Okay. So we end up with 5x is equal to negative 6, divide by 5, divide by 5, cancel, cancel, x is equal to negative 6/5, or plus 3, cancel, cancel, x is equal to 3. And then, of course, that means the answer's in set notation or something like that. All right, let's move on to the next one. Again, we have a quadratic. We know because we have a square right there. If we want to solve it through the zero factor property, the first step is set it equal to 0. All right, so minus 39x plus, oh, sorry, minus 54. There we go. So minus 39x minus 54. All right, that gives me a 5x squared minus 39x minus 54 equals 0. All right. Now at this point, we have to multiply the leading coefficient by the constant over here, so it ends up being 5 times negative 54 equals negative 270. I hate doing problems like this in examples because obviously you're dealing with larger numbers here, but the reality is sometimes my math lab will spit out horrible numbers and you do have to know how to deal with it. So apologize in advance, but you can do this, okay? It's just going to take a little bit more time and you just have to be really careful, right? So we're looking for two numbers that we can multiply together to get the negative 270 that if you add together would give you a negative 39. So you know the negative one must be on the right, the one with the higher absolute value, and the positive one must be on the left. Now, I want to point this out right off the bat, right? You don't have to do all of these. I'm going to write them out, but don't feel compelled to write all these, right? You know the first few are not going to work out. There's no way a combination of 1 and 270 or 2 and 135 is going to give you a 39. That's just not going to happen, right? So by all means, if you know they're not going to work, I mean, skip it. It's fine. You can kind of skip around. I'll show you a shortcut in a little bit, but it's not a very good shortcut. All right, so we're still not quite there, are we? See? 5 and a negative 54. Guess I really should be writing the results of this as I go. There we go. So this right here will give you negative 269. This will give you negative 133. So these numbers are just way out of whack. There's no way this is going to work, right? And this will give you negative 49. So we're getting pretty close, right? We're looking for the 39. Right? So we're looking for this number right. Yeah, we're looking for this number right here. The negative 39, and we're all the way to negative 49. So we might just be a couple away. So let's see what happens, right? So again, it seems like a really terrible number, 270. It kind of is, but again, as long as you're careful and you just go through the algorithm, you can find the answer. It's okay. So 6 plus negative 45 would give you a negative 39. And we found it. So it seems like such a terrible problem, but it only took 1, 2, 3, 4, 5 steps. And you got it. Cool. All right, so here we go. Parenthesis, parenthesis. Try to stick with me on this slide and divide method. Square root of x squared is x. Because it ends in a negative, it's going to be a positive negative. And we're going to put the positive next to the 6 and the negative next to negative 45. Now, at this point, we're going to divide it by the leading coefficient, right? That's where I get the 5, right? That's where I get the 5. Just try to... no, that looks terrible. Sorry. There we go. Okay, so we divide these by... we divide the number at the end. Longer arrows needed. We go all the way over here and divide that by 5. Now, if it doesn't go in, slide it to the front, right? So we say 5x plus 6. But if it does go in, you need to simplify. Negative 45 divided by 5 is negative 9. Okay, now you know 5x plus 6 multiplied by x minus 9 is equal to 0, meaning that either 5x plus 6 is equal to 0 or x minus 9 is equal to 0. And that should make logical sense, right? 0 times anything is 0, or anything times 0 is 0. So one of those must have been 0. One of these parentheses must have been 0 for that the product to equal 0. So hopefully that makes sense. The zero factor property should make intuitive sense, hopefully. Okay, so at this point we divide both sides by 5, and we end up with x equals negative 6/5. Over here we say plus 9, cancel, cancel, and x is equal to 9. All right, so we end up with negative 6/5, and over here we end up with a positive 9. Now, if you're sufficiently motivated or you have the time, go back and check your work. I'm not recommending you check your work all the time, but if you do have the time to check your work, you probably should. On a major test, a major exam, when it really counts, on the final exam, midterms, whatever, check your work. And you're not going to get good at checking your work if you never do it. So you'll get faster and more accurate at checking your work the more you do it. So if you don't check your work because you think it takes too long, you're not very good at it, the only way that I know to get better at it is to practice. And there you go.